Humans have wondered whether there is intelligent life elsewhere in the cosmos since time immemorial, because it is difficult to imagine that we are alone in the vastness of the universe. For centuries, we've only had evidence that only the Earth supports life, but a groundbreaking discovery is about to change all of that. Scientists have finally discovered new signs of life on one of Jupiter's moons. Which of Jupiter's moons supports life, and what type of life it supports? Join us as we explore the intriguing discovery of hints of life on Jupiter's moon Europa. Despite the huge distance, we have always been interested in what is going on around Jupiter, the largest of all the planets in the solar system. Jupiter glows brightly in the sky despite its distance of 365 million miles from the Earth and 601 million miles at its farthest. Venus is the only planet that is always brighter than the gas giant, but Mars can give it a run for its money at times. Part of this is due to its size and composition, since the planet gets brighter and dimmer as it gets farther away from Earth. How long will it take you to get to Jupiter, assuming you're interested in going? The time it takes a spacecraft to get to Jupiter is determined by a number of factors. A spacecraft's path often varies as it slingshots off of planets, moons, and even the Sun to gain acceleration while using less fuel. For example, the Galileo spacecraft launched in October 1989 and took just over 6 years to reach Jupiter, arriving in December 1995. However, the craft took a very circuitous route to reach Jupiter, traveling 2.5 billion miles around Venus, Earth, and the asteroid Gaspara. On the other hand, Voyager 1 launched on September 5, 1977, and made its closest approach on March 5, 1979. NASA accomplished this by constructing the Voyager mission to take advantage of the outer planet's perfect architecture. Another mission, New Horizons, had a more direct path after launching on January 19, 2006, and flew by Jupiter on February 28, 2007, on its way to Pluto and other dwarf planets. The journey to Jupiter took just over 13 months. As the Earth goes around the Solar, Jupiter takes 11.86 Earth years to complete one orbit of the Sun. Once every 398.9 days, we catch up with Jupiter, causing the gas giant to appear to migrate backward in the night sky. Jupiter has a vast number of satellites. According to NASA, Jupiter has 53 named moons, with additional awaiting naming. Jupiter has 79 moons, according to experts. There are many interesting moons orbiting the planet, but the first 4 moons identified beyond Earth, known as the Galilean Satellites, are of particular scientific significance. The Galilean Satellites are Jupiter's 4 largest moons, named after Italian astronomer Galileo Galilei, who first observed them in 1610. These large moons are named Io, Europa, Ganymede, and Callisto, and each is a distinct world. It is the most volcanically active body in the solar system, and its surface is covered in sulfur in various color forms. As it travels in its slightly elliptical orbit, Jupiter's immense gravity causes tides on the solid surface. Ganymede is the biggest moon in the solar system, surpassing even Mercury in size. Callisto's surface is heavily cratered and ancient, a visible record of events from the solar system's early history. But the very few small craters on Callisto's surface indicate a small degree of current surface activity. Ganymede is the only moon known to have its own internally generated magnetic field. Europa is Jupiter's 4th moon, and you'll learn more about it in this movie. The search for life beyond Earth has taken various forms. Despite its current terrible conditions, Mars, our neighboring globe, appears to have been hospitable, perhaps to Venus, but scientists' attention has recently turned elsewhere to Jupiter's moons. To begin, what kinds of evidence do scientists seek for while looking for life on other planets? Dr. Anne Youngblood, an expert on life in severe environments, and Dr. Paul Kenrick, an expert on the early evolution of life, discuss what they search for in the water. Almost all of the processes that make up life on Earth can be broken down into chemical reactions, and most of these reactions require a liquid to break down substances and allow them to move and interact freely. Because liquid water serves as a solvent, it is an essential requirement for life on Earth. It has the ability to dissolve molecules and facilitate crucial chemical events in animal, plant, and microbial cells. To perform the dozens of functions required to sustain sophisticated life, many complex molecules are required. Carbon is the simple building block required for organisms to create organic substances, such as proteins, carbohydrates, and lipids. Because carbon-based nitrogen is one of the most prevalent chemical elements on Earth and a key component of all living species, one working idea is that life on other planets could likewise be carbon-based nitrogen. The complex proteins for essential life are made up from smaller compounds called amino acids, simple organic chemicals that contain nitrogen. Carbon is a crucial component of organic substances, but it can't do it alone. Nitrogen is also required for the bearers of the genetic code for life on Earth, DNA and RNA. Many bacteria have the ability to transform nitrogen from the air into a form that can be utilized by living cells. Phosphorus, sulfur, and position are other items scientists check for. The last item, location, determines the correct distance from the sun or star that the planet or other celestial body orbits. Scientists discovered signs of life on Jupiter's moons because Earth is in the Goldilocks zone, which means it is just the correct distance from the sun and is neither too hot nor too cold to contain liquid water on its surface. Europa, one of the moons with a diameter of 3,100 kilometers, has received a lot of attention. Europa is slightly smaller than Earth's moon and orbits Jupiter at a distance of 718 million kilometers from the Sun, where the surface temperature never rises above minus 160 degrees Celsius. A new model from NASA scientists backs up the theory that Jupiter's moon Europa's interior ocean could support life, and they've calculated that this water, which is thought to be an ocean beneath the surface, could support life. This work, which has not yet been peer-reviewed, is presented for the first time at the virtual Goldschmidt conference and may have consequences for other moons in the solar system. Since the Voyager and Galileo spacecraft's flybys, scientists have believed that Europa's surface crust floats on a subsurface ocean, but the origins and composition of this ocean have been unknown. Researchers at NASA's Jet Propulsion Library in California modeled geochemical reservoirs within Europa's interior using data from the Galileo mission. Lead researcher Mohit Malwani Vaswani said they were a wonderful discovery. The researchers discovered that ocean worlds like Europa can be formed through metamorphism, which means that heating and increased pressure caused by early radioactive decay or later subsurface tidal movement would cause the breakdown of water containing minerals and the release of the trap. They first assumed the ocean was still sulfuric, but their models, together with evidence from the Hubble Space Telescope revealing chloride on Europa's surface, indicate that the water became chloride-rich. In other words, its composition resembled that of Earth's oceans. As a result, the scientists decided that the ocean could be extremely hospitable for life, and that Europa offers one of our best possibilities of discovering life in our solar system. These findings could aid NASA's Europa Clipper mission, which will explore Europa's habitability in the coming years. Their models suggested that the oceans on other moons, such as Europa's neighbor Ganymede and Saturn's moon Titan, may have evolved through similar mechanisms. The researchers are currently collaborating with labs in Nand and Prague to see if seafloor volcanoes played a role in the formation of Europa's chloride-rich water. New high-resolution photographs of Europa were just provided by NASA, suggesting potential expedition sites to test these results. Thank you for watching. Let us know what you think of life in Europa in the comments area below, and this is Tech Revelations.